Hello, my name is Miriam Blomberg, and I chose to do my chiral molecule case study on threonine. It's January 15th, 2026. Moving into the IUPAC name, we got a 4-carbon chain, which makes the bute prefix, and then a carboxylic acid, which puts the oic acid on the suffix, and then an amino group on carbon 2 and a hydroxy group on carbon 3, and then a methyl group at the end. So that's 2-amino 3-hydroxybutanoic acid. Here are the functional groups: carboxylic acid in pink right here, amine group here, and alcohol group here. I labeled my chiral centers with a purple asterisk at carbon 2 and carbon 3 because it has 4 different groups around that carbon. And 2 chiral centers could mean that it could be chiral or achiral, but we know it's chiral because there is no line of symmetry and it's not non-superimposable. Going into the stereoisomers, we know there are 4 stereoisomers of this molecule because I do 2 to the n being the number of chiral centers. So there are 2 enantiomers and 2 diastereomers. Here are the enantiomers. I assigned priority to each chiral center on these wedge dash drawings, and if the hydrogen is wedged, the configuration switches, as you can see in the 2R3S molecule, and you can see that all the chiral centers configurations were flipped, so that makes it an enantiomer. Here are the diastereomers of this molecule. As you can see from the drawings, only one of the chiral centers flipped on each one and not all of them. And then we go into the constitutional isomers, which have the same molecular formula but different atom connectivity. So they're all C4H9NO3. And here we can just see that the atom connectivity changed by moving the methyl group, the amino group, and the alcohol groups or hydroxy groups have just switched around. And then the molecular geometry of this molecule: carbon 1 would be trigonal planar, sp2 hybridized, carbon 2 tetrahedral, sp3 hybridized as also carbon 3 and carbon 4, and then the nitrogen / amino group would be trigonal planar, or trigonal pyramidal because of a lone pair on the nitrogen. And then why is this molecule important? Because threonine is used in protein synthesis and is an essential amino acid that we must obtain from our diet. It's used in glycoproteins, antibodies, and enzymes. And this is vital for metabolism, immune defense, and cell signaling. Its presence in these molecules highlights its importance in maintaining overall health and biological function. Thank you.